Suppose you're in charge of product distribution at your company. There are multiple factories that deliver to multiple store locations. Your job is to come up with a delivery plan that optimizes company resources. And this is exactly the problem of optimal transport mapping. When we were learning this concept ourselves, we did not find any resources that visualize the problem in a straightforward manner. So our goal with the following interactive elements is to take the user through the problem in a step-by-step fashion by emphasizing the conceptual foundations rather than the mathematical formulations of optimal transport mapping. Let's look at the most simple case. Say there's an equal number of stores and factories. Each factory produces the same amount of products and they only deliver to a single store. Here the red dots represent the factories and the blue represent the stores. The interaction allows the user to map each red dot to a blue dot by clicking on it. The box on the side keeps track of the cost of the mapping and displays a message at the end indicating whether it's optimal. We implemented flickering animations to draw the viewer's attention to certain parts of the visualization.
Let's move on to a more complex case. Say there are a different number of stores and factories. Each factory produces different amounts of products, but they still only deliver to a single store, each with a different supply demand. Here, the area of each dot reflects the amount of product produced or needed, which is also labeled for easier comparison. Finally, let's consider the case where each factory produces different amounts of products and also deliver to multiple store locations. To visualize this mass splitting, we made it so that each click on a blue point distributes 1 unit of mass from the red point. We keep track of the amount of mass being distributed between 2 points by labeling the arrows, which updates on each click. Based on newly gained knowledge from these interactive exercises, you are able to implement an optimal delivery plan for your company that minimizes the amount of resources for transporting the products from the factories to the stores. Our visualization both effectively explains optimal transport as a concept and demonstrates its increasing complexity, as finding computationally efficient ways for calculating optimal maps is an area of ongoing research in machine learning. Overall, optimal transport has applications in many areas including image processing, computational neuroscience, and natural language processing.